Hi guys, welcome to a new episode of MrLopezClasses.com. This is the first and the second chapter of our Marine Electricity Handbook. This is the Marine Electrical class. This course is divided in two sections. The first section is basically DC current, DC power, and the second part of the course is AC powers. In the first section, in the DC current, we are going to cover the first 8 chapters. The first 8 chapters of our Marine Electrical Handbook. The first 8 chapters will be related with the DC current. We are going to cover the nature of matter, electrical current, batteries, conductors and isolators, type of circuits, cranking and charging systems, DC panels, and the dashboard. Yes, the last chapter is the dashboard. The last 2 chapters, the DC panel and the dashboard, we are going to do the wiring of a complete boat, the DC portion of the boat, including the dashboard with the fuel gauge, oil temperature sensor, all of the sensors, all the gauge, the tachometer, the hour meter, the ignition switch, the alternator, the start motor, all of those equipments integrated with the DC panel and the group of batteries. This is the first section of this book. The second section will be AC power, and we are going to do the AC wiring for single phase, double phase, including the generator, the inverters, the transformers, and we are going to learn the procedure to convert from 60 Hz to 50 Hz, European to American, and at the end we are going to talk about the solar boat, solar panels, and configuration of those panels. This is our electrical class. This course is an excellent complement in order to take the electrical ABYC certification. Yes, the course, the book follow the standards of ABYC all the time. I follow the standards of ABYC. This class is exactly the same content when I teach this class in other universities related with marine electricity, MTE 1004 and MTE 2024C. Those courses are part of this class. This program covers those electrical classes. And this course is an excellent complement in order to take the electrical certification. We are going to practice at the end of each chapter with a couple of questions related with ABYC. I am going to mention during the videos this particular explanation is an ABYC question, or I mention where is ABYC related with my video. I hope that you enjoy the video. This is not only the video, the book. This is, in my opinion, my bestseller. I love the electrical class. A lot of people in the world follow my classes, especially the electrical class. I hope you enjoy this class the same that I enjoy prepare each video, each class, each laboratory for yours. This is my passion, and I am too happy to start with yours today, my electrical course, my electrical class. Alright, in order to understand easily electricity, we need go down, a little down, in order to understand how the electricity flows. What is the meaning of electricity? Why we have electricity in my home? Why I have electricity in my battery? Why the power on the battery is different like the power of the outlet? How many panels I have in my boat? How can I create the wiring in my boat? There are millions of questions, but in order to understand those questions easily, we need to go to the basic, to the fundamentals, and we are going to pass quickly that theory. We need to understand the matter and what happened with the matter and how the matter is organized in this magic periodic table, and why the elements are located here or here or here. What is the criterion in order to organize the elements in the periodic table. And who organized the periodic table? All right, we are going to start right now in order to follow that theory. The chapter 1 is related with the nature of the matter. We are going to talk about the atomic number, the atomic weight, the electronegativity, the ions, the octet rule, very, very important, the molecules, process of oxidation and corrosion, and static electricity. All right. Basically, the matter is made of atoms, and each atom is composed of protons, neutrons, and electrons. This is similar to a solar system. You remember with the sun and the planets orbiting around the sun, it's exactly the same. We have the nucleus. We have the nucleus in the middle. This is the nucleus. And we have the planets, in this case are electrons. The electrons orbit around the nucleus. This is basically the atom. And how the electrons rotate around the nucleus and never are separated is because the charge of each atom is, the final charge is 0. Each atom is stable. What is the meaning of that? The charge, the positive charge and the negative charge are equalized, are balanced. Yeah? The atoms is a composition of a positive charge, protons, negative charge, electrons, and neutral charge, neutrons. In the nucleus, you have protons and neutrons. In the nucleus, here, you have protons plus neutrons. In the orbits, you only have electrons. That's the atom. And in the periodic table, there are organized all the atoms are organized according with the amount of energy, and especially with the amount of electrons in the last orbit. According with the amounts of electrons in the last orbit, the atoms are organized in the periodic table in a specific position. Right now we are going to talk about that. The atoms have the same number of protons and electrons. What is the meaning of that? If an atom have 3 protons in the nucleus, it's because the atom have 3 electrons in the orbits. Because remember, the atom is stable. Okay. If this atom, for example, iron, how many electrons have in the last in all the orbits? 26 electrons. 100% sure that iron in the nucleus have 26 protons. What about carbon? Carbon have 6 electrons in total. 6 electrons in total. In the nucleus have 6 protons, because the number of protons and the number of electrons are exactly the same. Okay, most atoms have approximated the same number of neutrons than the protons. What is the meaning of that? In the nucleus, there are protons, positive charge, and neutrons, neutral charge. The idea is that in the nucleus there are the same amount of neutrons and protons, but it's not a rule. Not always the nucleus have the same amount of protons and the same amount of neutrons. There are nucleus with more neutrons. No problem, because the charge of the neutrons is 0, is neutral. What happens if I have extra neutrons? If I have extra neutrons, the weight of the atom, is more weight, more heavy. All right. The number of protons are equal to the number of electrons. And about the neutrons are located in the nucleus with the protons. In the nucleus there are protons and neutrons. Normally the neutrons are a little more neutrons than protons. I'm going to explain later that concept. But no problem, because the neutrons don't affect the final charge of the atom. The neutrons, the excess of neutrons, only affect the weight of the atoms. Okay. Most atoms have approximated the same amount of neutrons than the protons in the nucleus. That's the explanation. Okay. With this information, we are going to introduce one important concept, and the concept is the concept of an atomic number. What is the meaning of the atomic number? And I have this example, the example of lithium. Lithium in the periodic table, have three electrons or 3 protons in total. The atomic number of an element refers to the number of protons or electrons in the atom. Okay, in this particular case, lithium have 3 electrons in total or 3 protons in the nucleus. All right? And what is the meaning of the atomic mass? Excuse me, I return to this slide. Lithium have 3 electrons or 3 protons. It's exactly the same. And this is the atomic number and is located on top. Okay, what is the atomic number of copper? Is 29. What is the atomic number of aluminum? 13. What is the atomic number of zirconium? Is 40. Is the top number is the atomic number. The atomic number is the number of protons or electrons. Okay, now we are going to refer to the number in the bottom. The number in the bottom, this one. The number in the bottom. The number in the bottom is the atomic mass. The atomic mass or weight of an atom is determined by the number of protons and neutrons in the nucleus. Remember, the electrons are a little small and they have less weight, and they are spinning around the nucleus. In normal conditions, the proton have 1836 times the mass of the electrons. It's too heavy, but exactly the same opposite charge. Yeah, the charge of the proton is positive and the charge of the electrons is negative. And now, with that concept, we are going to try to understand one important concept, is the concept of electronegativity. But before I introduce the electronegativity, I want to explain something. For example, we say that lithium have 3 electrons in total. Where is located lithium? Lithium is the second element in the first group. The periodic table is organized in groups. There are A principal groups. Group number 1, group number 2, group number 3, 4, 5, 6, 7, and 8. Those are the A principal groups in the periodic table. And this group in the middle, the name is transition metals, and we are going to talk later about that specific group located in the center, located in the middle. Okay, what happened with the main principal groups? How the elements are organized in the main principal groups? The elements are organized in the main principal groups according with the amount of electrons in the last orbit. For example, if I have lithium, suppose that I have lithium, and lithium have 3 electrons or 3 protons in the last orbit. The atomic number of lithium is 3. What is the meaning of that? In the nucleus, there are 3 protons plus other neutrons. I don't know how many neutrons are. This is not important. But in the last orbit, 1 electron, and in the previous orbit, 2 electrons. What is the meaning of that? In total, 3 electrons. But in the last orbit, or in the outer orbit, only 1 electron. All the elements located in the group number 1, they have 1 electron in the last orbit. All the elements located in group number 1, they have 1 electron in the last orbit. Let me check. Lithium in total have 3 electrons, but only 1 in the last orbit. What happened with the other 2? The other 2 are in previous orbits. What about sodium? Sodium have in total 11 electrons. Sodium have 11 electrons in total. Only one in the last orbit, the other 10 in previous orbits. The most important is how many electrons are in the last orbit. In this particular case, the elements located in group number 1, they have one electron in the last orbit. Doesn't matter how many electrons are in the previous orbits. All of those, they have one electron in the last orbit. What about the element located in the group number 2? 2 electrons in the last orbit. For example, calcium. In total, 20, but in the last orbit, 2. Very, very important. What about aluminum? Aluminum is located here in the group number 3. 3 electrons in the last orbit. In total, 13. 3 in the last orbit and 10 in the previous orbits. What about phosphorus? Phosphorus is group number 5. In total, 15. But in the last orbit, 5. The other 10 in previous orbits. What about chlorine? Chlorine, 17. 7 in the last orbit because it's group number 7. And 10 in the previous. What about those elements with 8 electrons in the last orbit? When an element has 8 electrons in the last orbit, that element is considered stable. When an element has 8 electrons in the last orbit or 0, the element is considered stable. For that reason, what is the name of those elements located in the group number 8? Noble gases. Those are gases. And they are nobles. What is the meaning of nobles? They don't react. They are noble. Okay? They are stable. They don't react with any other element. They are stable. What is the rule? In order to consider an element stable, the element is stable if in the last orbit or valence orbit, the element have 8 electrons or 0. All the elements try to be stable. What is the meaning of that? All the elements are in the environment trying to complete 8 in the last orbit or 0 in order to be stable. Like yours. What are you doing here? Checking the video of Mr. Lopez. You try to study in order to produce money and be stable in your home the rest of the life. Yes or no? All the people try to work and collect money in order to live in calm, in peace, in order to be stable. This is exactly the same. This is exactly the same with the atoms, with the elements. They try to complete 8 electrons in the last orbit or 0 in order to be stable. For that reason, there are processes on the environment, oxidation and corrosion. It's because the oxygen tries to complete 8 and oxidize everything. We are going to talk later about that. Alright, until this point is clear, this is the name of that rule is the octet rule that we are going to talk right now. Alright, when the elements are located in those groups, group 5, 6, 7, the elements have more energy. When the elements are located in the group number 1, number 2, those elements have less energy. It's simple. They have only 1 electron in the last orbit or 2 electrons. Yeah? When the element have 5, 6, 7 electrons in the last orbit, they have more energy. Let me explain something. The electrons are spinning around the nucleus, but additionally, each electron is spinning through your axis. That's the spin of the electrons. They orbit around the nucleus, and additionally, they spin. Okay, if you have 7 electrons in the last orbit spinning each one, it is a lot of energy. If you only have 1 electron around the last orbit spinning, it's low energy. According with the level of energy of each element, you say that each element have more electronegativity or less electronegativity. And this is the next concept that we are going to introduce right now. What is the meaning of electronegativity? And there are different definitions, but I want to express my own definition because I consider that it's too simple. This is the definition of other author. Electronegativity is a measure of the tendency of an atom to attract bonding electrons. I explained that situation before. The elements try to complete a electrons in the last orbit in order to be stable. Of course, the element with more energy attract the extra electron from the element with low energy easily because those elements have more energy. That's clear? Alright. For example, I said in this slide, fluorine. Where is located fluorine? Fluorine is located here in the group number 7. It's located here in the group number 7. This is the element in the periodic table with the highest level of energy. What is the value of the level of energy of fluorine? Is 4.0. 4.0. We are going to think, for example, in millivolts. Okay, millivolts. 4.0 millivolts. This is the level of energy of fluorine. That's too much. And the element in the periodic table with low level of energy is francium. Francium is located here. Look, this is francium in this corner. The element located here, they have low energy. And the element located over there in this corner, they have the maximum level of energy. That's too simple. The elements located in this corner in the bottom, those elements have the lowest level of energy. And the elements located in this corner, they have the highest levels of energy. Simple. The element with high level of energy try to suction the electrons of the elements with low level of energy. That's simple. Elements like oxygen with high electronegativity, because oxygen is located in this magic corner, tend to attract electrons from other atoms. Yeah? Oxygen located, the elements with high level of energy in the periodic table are, look, oxygen 3.5, fluorine 4.0, chlorine 3.0. Those are the elements with high level of energy. The rest of the elements, they have 1.6, they have 1.9, 1.4, and this one 0.7. 0.7 with the low level of energy. Okay, the element with high level of energy, like fluorine, chlorine, and oxygen, they try to attack everything. Yeah, now you understand why the chlorine used to do the service of the pool in your home attack everything. You remember how is the pickup truck of the technician that visit your home to repair the pool? It's completely corroded because those technicians, they manipulate a lot of chlorine, and the chlorine corrode everything, attack everything, because chlorine is located here with 7 electrons in the last orbit. How many electrons additional need chlorine to be stable? 1. For that reason, attack everything in order to suction that electron and be stable. That's the situation. Other element. What is the element in the environment with higher level of energy corroding everything every day at any moment? Oxygen. Oxygen with 3.5 is too much energy. How many electrons, extra electrons, need oxygen to be stable? 2. For that reason, oxygen attack everything. Oxygen corrodes everything. And the name of that process is oxidation. Oxygen attack oxygen oxide. Alright, it's clear? That's the origin of that word, oxidation. Is when the oxygen attack other element in order to complete A electrons in the last orbit. Quiz question. Okay, according with this, we can talk about the ions. Let me explain one situation before we continue. We are going to check, for example, what happened when the oxygen attack one element of the group number 2. How many electrons have oxygen in the last orbit? 6, no? 6 electrons in the last orbit. How many electrons need oxygen to be stable? 2 additional. What happened if the oxygen founded one atom of calcium in the environment? Calcium. How many electrons have a calcium in the last orbit? Calcium is in the group number 2, and calcium have 2 electrons in the last orbit. What element have more energy, more electronegativity in between oxygen and calcium? Of course, oxygen, because oxygen is located in this corner and calcium is here, low energy. What is the element that attract the electrons? Oxygen. And what is the element that release the electrons? Calcium. Because calcium have low energy. In that particular case, what is the more noble element? Oxygen. And the less noble? Calcium. Okay. Alright. This element release 1 electron and release other electron. And oxygen complete 8 and calcium complete 0. And the molecule right now, the molecule CaO is stable, and this is a perfect molecule. We are going to talk later about the molecules and about that rule, the octet rule. Alright, this is a typical example. Alright, let me explain something. In terms of ions, in this particular molecule, the molecule of calcium and oxygen, what is the element that suctions electrons? Oxygen. In other words, at the end of the day, at the end of the equation, at the end of the process, what element is more negative? Oxygen, because oxygen put in your pocket 2 additional electrons. Plus 6, right now have 6 negative charge in your pocket. What is the more negative ion? What is the ion of oxygen? The ion of oxygen is negative, because it's supercharged with negative charge. And what about calcium? Calcium released 2 electrons and now is more positive. When an element releases electrons, the element become more, release electrons, the element become more positive. When the element attract electrons, the element become more negative. In this particular molecule, oxide of calcium, the ion of oxygen is negative and the ion of calcium is positive. It's simple. Yeah? The element that attract the electrons become more negative, and the element that release the electron become more positive. Simple. And this is the explanation about ions. Ionization. Ions. Ionization. When energy is added to an atom by some exterior force, like a heat, friction, or when you have a flow of electrons bombarding, the atom is excited. What is the meaning of that? How can I do to produce that the electron jumped from one orbit, the last orbit of one element, into the last orbit of other elements? You need excite the atoms in order to produce that jump of electrons from one orbit into the other orbit. This is the excitation process. How can you do that? By temperature. When you add temperature, the atoms are excited and try to jump it into other orbit. Simple. Or with a biochemical reaction, or by centrifugal force. For that reason, the nuclear reactors, they produce high centrifugal force on the atoms, and the atoms in the last orbit jump it into other elements. Yes, by centrifugal force, this is a mechanical movement, or by excitation with a high temperature or high pressure, the element jump it into other orbits. The most common is for high temperature, and the most common is for excitation with the electricity. We are going to talk later about that. Okay, my friend. But in general terms, the ions is the value of the charge of each atom at the end of the process. We are going to study other molecules right now, and we are going to check how are the ions at the end when the molecule is created. Okay. Ionization. Ions are formed when atoms or a group of atoms lose or gains electrons. The metals normally lose electrons, and the metals becomes positive, because when the element lose electrons, the element become positive. I'm going to explain right now that situation. And the non-metals normally they gain electrons. I forget to explain something in order to understand this slide. Let me explain. You can see that division, that section. Okay, this is an important division in the periodic table. The elements located below the divisions are considered metals, and the elements located over the division, they are considered non-metals. Nitrogen, phosphorus, sulfur, oxygen, fluorine, chlorine, those are non-metals. And the rest of the elements located here are metals, except one. Which one? Yes, hydrogen. Hydrogen is located in the group of metals, but hydrogen is not a metal. Hydrogen is located here only because the structure have one electron in the last orbit and is organized in the group number 1. But this element should be located here with the gases. But for a structure is located here, only for the structure. It's not because it's a metal. Hydrogen is not a metal. It's clear, my friends? Metals below the division and non-metals over the division. Simple. Of course, the elements located here with high energy, the non-metals, they try to suction electrons from the metals. Simple. This is the explanation here. Non-metals gain electrons and form negative charged ions. They attract electrons, and they are more negatives at the end of the day. The ions of the non-metals in the molecules are the negatives. And right now we are going to check a couple of examples about that. Alright, in the previous example, in this example, I say to you that I put the example of the molecule of calcium and the molecule of the atom of calcium and the atom of oxygen. And this is an unstable molecule, because at the end of the day, oxygen complete A and calcium 0, and the molecule is perfect. Give me an example, my friends, of other perfect molecule. What is the meaning of perfect molecule? It's a molecule that not react because it's stable. All the elements involved in the molecules are stable. What is the meaning of molecule? A molecule is when you have two or more atoms together. This is a molecule. Or compound. I'm going to explain later the difference between compound and molecule. When you have two or more atoms together, creating a molecule. Give me an example of a molecule, perfect molecule, that not react. You have a liquid that you drink every day and is stable. Yes, water. When you drink water, water is stable. Water not react. Okay? Let me check the formula of water. You remember the formula for water, my friends? Can you refresh to me the formula for water? Let me clean my board and I check the formula for water. The formula for water is H2O. Let me check the formula. Okay, oxygen and 2 hydrogens, no? 2 hydrogens. Okay. How many electrons have oxygen in the last orbit? Yes, 6 electrons in the last orbit. Okay, 1, 2, 3, 4, 5, 6. How many electrons have hydrogen in the last orbit? Only 1. Only 1. Perfect. Only 1 here and only 1 here. Alright, what element have more energy? Oxygen or hydrogen? Yes, oxygen. And the other one, hydrogen, less energy. What is the element that suction the electrons? And the element that release the electron will be hydrogen. Okay. Hydrogen release the electrons. Hydrogen release the electrons. And at the end of the day, oxygen complete 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen 0 and 0. Oh, perfect. Right now the molecule is stable and this is a perfect molecule. The molecule of water. This is a perfect molecule. It's a stable molecule. You like it? Give me other example of other molecule in the environment that is perfect. What is the name of that relation? That relation is an ionic bonding. Ionic because it's permanent. Can you separate easily the hydrogen from the oxygen in the water? Easily. No, it's not easy. You need a process. The name of the process is electrolysis in order to separate the oxygen from the hydrogen. But it's not simple. It's a special process. Alright, in other words, the oxygen and the hydrogen in the molecule of water is perfect. Is practically indivisible. Yeah, it's strong. For that reason, the name of that bonding is ionic. It's permanent. It's permanent. Okay, give me an example of other molecule that you have in the environment and you breathe every day, every moment, every second, every millisecond. What is the name of that molecule? O2. My friends, when you breathe oxygen, you breathe O2. No single oxygen. If you breathe single oxygen, that's not good. I'm going to explain right now what happened. You breathe O2. That's the oxygen in the environment. And this is the oxygen that you need to continue in this business. Oxygen. Okay, let me check the molecule of O2. What happened with that molecule? Alright, we have two oxygens. And each oxygen with 6 electrons in the last orbit, 6 and 6, and 6 and 6, and how many electrons need each atom to be stable? A and A or 0 and 0. In this particular case, they can share 2 electrons together, and they have A, and the molecule is good. But that business is not permanent. That business is temporary. With any other external situation, the atoms are separated and the molecule is separated. This relation is covalent bonding. It's not permanent. This is non-permanent. In other words, the molecule of oxygen is a perfect example of a covalent bonding. Why? Because in the last orbit, both of them have 2 electrons. Those 2 electrons are right now part of the bonding connection, and each of those atoms complete 8 electrons in the last orbit, and the molecule is stable. What is the meaning of oxidation? Like I explained before, is the interaction of oxygen molecules with any other metal with less electronegativity. Yeah, I explained to you that the oxygen located in this corner with high energy attack the rest of the metals located over there below the division with less energy. This is the process of oxidation. It's basically the atoms of oxygen attacking the atoms of any metal, producing oxide of metals. Those oxides are the final product of the reaction in between the oxygen and the metal. Later we are going to talk about corrosion.